Well, we have seen that in the past 1.5 decades, the scientific community seems to have agreed that indeed it is. 2005, there was this influential paper by John Ioannidis on why most published research findings are false. And since then, a lot of fellow researchers and colleagues seem to agree that indeed we do have a bit of a reproducibility crisis. And of course, the question then is, well, do we do anything about it? And indeed, there are indications that papers are still being published, but things might be getting better. But we have also new technologies arriving, which bring new challenges, such as artificial intelligence and the black boxing of analysis and the unknown or known biases of training data and model output. So it seems that the focus maybe has only shifted. Now it used to be psychology. Now it's AI that's wrestling with the replication crisis. So things are improving, but still a lot needs to be done. And I guess most of you have already encountered the terms, especially since this is an open science event. However, the terminology is, let's say, diverse. And so I think for establishing common ground here, I'd still like to show you my definition as I will use it here in the talk. So reproducibility here means that we have the same results or outcomes when we use the same data and the same methods. And so if the outcomes are identical or within an expected margin of error, that's great. So probably the research itself works. Replicability means that we change something. We can change the input data, we can change the methods, because we're looking for patterns here in science, right? We want to know whether some assumptions or laws are universally true. And so, well, if the outcomes are similar, then the original hypothesis is supported. If not, it's not automatically falsified, but at least it seems to be of limited generalizability. And clearly here, so reproducibility is more concerned with the research design itself, the study itself, and replicability is more concerned with the outcomes, with the contribution to science, let's say. So one could think or say that replicability maybe is more important, but it will be very difficult to achieve replicability without any reproducibility. So as I said, for open science, what we want to is understand our world, and we need to know when things should work and when they shouldn't. And without any reproducibility, replication is very difficult. If you don't know which factors exactly you change, how can you interpret the new results? And without replication, new knowledge will be automatically limited. So as James D. Nichols put it in this figure, ideally, if we replicate studies, then one of the hypotheses will gain more support than the others, and so we advance knowledge. Unfortunately, we all know that science funding, for example, is not very much interested in replication studies. And so it always calls for innovation. So we're innovating a lot, but we're not always sure whether this innovation is just a single idiographic observation or whether it works in general. But also for us as individual researchers, I think reproducibility is very useful, can help to avoid disaster. When something goes wrong, you don't have to redo the entire analysis. You can have several points of entry where you can restart it. Ultimately, it makes it easier to write papers. I think it's convincing for reviewers, at least me as a reviewer. I'm always easier to convince if you share as much as you can. It makes it easier to continue your own work, and it helps to build your reputation. And as you see in the right-hand figure, it may be that reproducibility or making a paper reproducible requires a bit more effort in the beginning, but since you will have to redo some analysis, since you usually have to revise parts of your work to be published, you will save time later. And my original motivation, as Marcus already told you, I'm interested in novel sources of geoinformation. And there especially, we don't know when these are useful, when these are applicable, under which conditions we can do which types of operations, and so on and so forth. I've listed three especially big problems that we have with geosocial media or volunteer geographic information, that's VGI, so OpenStreetMap, for example. Often the platform that you're working with is a black box, right? So you're not exactly sure whether you actually retrieve all the data that you ask for or not. Even Twitter API, for example, can be surprisingly inconsistent in what it returns to you. The content is volatile, so people can delete posts, people can delete information, and they should be able to do that. But for you as a researcher, it makes things a little bit more difficult. And then you also have the variance in human behavior. So there are some studies that show if you let people classify something, some information, for example, even the same person will often not classify the same information in the same class again after a while, right? So there's a lot of variation also within our behavior. And so that led to a first study that I did with Carlos, which you see in the right-hand side from 5 years ago, where we looked at what this means for studies that use volunteered geographic information. However, of course, we were not the only ones interested in this topic. And sooner or later, we found each other at a conference. Marcus was also working on a project related to this topic. Daniel Nüst was also one of the initiators, and he actually took the initiative to create a conference workshop at the Agile conference. And that's where it really started. 2017, we got together, and interestingly enough, there was a little interest in the workshop. And so we decided, that can't be. We need to change that. It's an important topic. And the first step that we wanted to do, and I will tell you a little bit more about this on the next slides, is to look at the state of affairs in our discipline. So we had a review paper out and more workshops, and ultimately there was an Agile initiative, a little bit of funding. We were able to devise guidelines for reviewers and authors, of course, to increase reproducibility. So I'll also tell you a little bit more about that. So it's really about the work of the last, let's say, 5 years. And well, some of you may have been wondering, what's this Agile actually? Isn't this about software development? Yes, it is. But it's also the Association of Geographic Information Laboratories in Europe. And it's quite a distributed network of labs that we have. And there is an annual Agile conference. There is also biannual PhD school. There are several Agile initiatives. So our reproducibility one was just one of several. And there are collaborations and memoranda of understanding with other organizations and other associations. So when you talk about geographic information science, I dare say that the Agile Association and the conference series is an important one that you would want to visit occasionally. So about the review paper, what did we do? So we looked at the Agile best papers. Those were 20 full papers, 12 short papers from 2010 to 2017. That's roughly 8% of the 253 full papers since 2007. We limited it to this to make it manageable for us as a team, because we wanted to manually investigate this. So we assigned 2 reviewers per paper. And first we needed to decide, is this a very conceptual or theoretical paper? If yes, then there's no point in looking for computational reproducibility. And so we excluded it from the further analysis, not because we think it's unimportant, but simply because our methods wouldn't work with it. So then we tried to assess the reproducibility, and if we agreed, then we would analyze and interpret the outcomes. If not, there was some additional discussion, and if third colleague joining, and if that wouldn't end in an agreement, we would ultimately vote. As a last step of the analysis, we wanted to learn what the authors were thinking of our approach and our assessment. And so we did a brief author survey in which we asked them, and more about that in the next slides. So the question is, how can you assess reproducibility? And again, this is not completely original. This is not coming out of thin air. This is based on a lot of other work that has been done before. And if you want to know which work, then I encourage you to read the paper that's displayed there. Quick anecdote. Originally, we wanted to publish this as a full paper at the Agile conference. However, our paper was rejected. And why was it rejected? Well, because it was way too long. Why was it way too long? Well, we had a long appendix about which we clearly said this wouldn't make it in the final paper, but because it's a double-blind review process, we couldn't give you, we thought this is the easiest way to provide the information to make it reproducible. So essentially, our paper was turned down because it was reproducible, because it was too long. Anyhow, so 3 dimensions: data, methods, and results. I think they speak more or less for themselves. And we also try to split up the methods into pre-processing, the actual methods and analysis, and the computational environment in which this is happening. More on this distinction later. And each of these dimensions could have one of 4 levels. So level 0 means it's unavailable and undocumented. It means there simply is not enough information to even attempt a reproduction. Ideally, this should never happen in a scientific paper, right? Well, level 1 means documented. So that means there's enough documentation that we actually can try to reproduce the paper. Level 2 means it's not only documented, it's also available. So there is input data available, there is code available, there is, for example, clear links, or it's clearly established how visualizations are created. And the third level is one additional tiny step: make it open, make it long-term available on a platform other than an ephemeral project website, ideally with a digital object identifier. So how reproducible were those Agile papers? What you see here is the 5 dimensions: input data, the 3 in the middle are processing and results. And then you have for each one the level. Some were not applicable. And what you can see is that the picture for the input data is quite alarming. So for a majority of papers that use data, we did not have enough information to even attempt to recreate the data. For the analysis and the results, fortunately, at least it was mostly documented in such a way that if we had the input data or would know how to recreate it, we could try to recreate the entire analysis. But still, very, very few papers giving us something like an actual code to run. So this is quite a sobering picture, I would think. Is there at least some improvement over time? Nope, there isn't. We didn't do a statistical analysis because the sample size is too small. And yes, we did the mean value of an ordinal scale. Very bad. But at least allows us to compare, right? So it's not that 2 is double of 1. As I explained from the levels, this isn't how it works. But still, it allows us to see whether there is some change over time. And, well, there's very little change over time. So what did the authors think about this? We gave them the evaluation of their paper, and 22 of 82 authors filled it in. the questionnaire, and most of them agreed with our assessment. Only very few completely disagreed with it. Most of it, some more agreed partly with it. And most reasons for disagreement were that they think these requirements were too hard for a short paper, which is an argument that we can, well, at least discuss. They think that specific data is not always necessary for reproducibility. That could also be. Many thought that availability upon request means available. This is a point where we strongly disagree, because it shouldn't be up to the whims of an author or the availability of an author to provide the data. And others also said that OpenStreetMap data, for example, is by default open and permanent, which also can get into a discussion about, but I don't think that's true, especially since OpenStreetMap data is very dynamic and changes over time. So if you don't tell me on which date, for example, you retrieved the OpenStreetMap data, then we still might be using very different data sets ultimately. So did they consider reproducibility? Again, short answer is yes, they did. But why then aren't the paper more reproducible? So reasons were legal restrictions, which is a valid one for some data sets maybe, not enough time. We all have not enough time to do everything we want. Some said also that they don't know adequate tools or don't know how to make it more reproducible. And of course, insufficient incentives, because indeed there is no direct reward for making your paper reproducible. So those are all things where we thought, let's do something about it. And as I said, we asked the Agile Council to give us a little bit of funding to set up a workshop, for example, with some colleagues from outside of our discipline. And you saw them in the first photo, a couple of slides back. And so what we came up with were guidelines that tried to make the papers more reproducible. And there is already a second version of these guidelines out, and they are also being translated into different languages. And some elements of these guidelines are that we provide a reproducibility checklist for authors, so they can go through a list and see whether they've done all they can to make the paper as reproducible as possible. We ask them to write a data and software availability section. So that's the DASA section, where they at least write what is available, and if it isn't available, why is that? There are also guidelines for the reviewers, how to look for this, how to work with this, and some background information on why we try to explain why this is so important to us. These guidelines ultimately have become quite a long document, but there is always a short, let's say, main message. If you only want to get the gist of it, then you can look at that. The important part is what we want it to be is also realistic. And we want it to be an encouragement and not an exclusion. So the idea is that we want to set positive examples that people want to follow because they see the advantages, and we do not want to exclude people from publishing if they, for example, are yet not able to make it more reproducible, right? So the idea was always to be kind and look at career stage knowledge and so on of the authors and encourage them, not punish them. Then we also organized a reproducibility review after the accept-reject decision. So you can see already it was not possible to integrate this directly into the original review process. You also know probably from experience with the conference, there's always a bit of a timing problem. So we did the reproducibility review after it was accepted. And then the authors had the opportunity to improve their papers if they wanted to. And if the paper was reproducible by if the reviewers could reproduce the paper, then what they would get are what you see on the right-hand side, these nice badges. So these badges indicate, when you look at the online proceedings, these badges indicate when we actually managed to reproduce the full analysis of a paper. So this doesn't work for all papers. It's slow going, but it's improving. So for 2021, for example, 9 reproducibility reports were published. 8 papers were not reproducible for various reasons, which you see here. So it's work in progress, but I dare say something is happening. We're moving into the right direction. So these reports are also published on OSF platform with a DOI and links to the original paper. So what we also hope that is that all of this will start to integrate a community, a network, and will reinforce each other so that there will be some positive feedback loop. So there is a lot of observations and lessons learned. I won't read them out loud here. I guess the slides will also be shared. Overall, with the conference, we faced 2 main challenges. One is the schedule, right? So there is very little time between submission and the need to have it fully accepted and published. Another problem was that the reviews, the submission and review process was initially double blind. So we had to wait until the papers were accepted to be able to communicate with the authors. And we tried to make it very clear that if we didn't attempt to reproduce a paper, it doesn't mean that it's bad science. However, as we saw later in the discussions when we presented our results, there is still some, let's say, convincing to be done that indeed this is not what we intended. So a few authors, not many, but a few were a little bit uneasy with the process. So it shows that change of culture is difficult and a long process to complete. So if you want to try this at home, then the recommendations that we have are build a team of enthusiasts, try workshops, social events. Of course, build this on what is there. So have a look at the current state to see where the main problems are and to raise awareness. Try to get some institutional support. That helped us a lot. Positive encouragement certainly is a good idea, and you need to keep going at it. So those are the outcomes from the Agile. And we will continue these various steps. But I would also like to report very briefly on the follow-up investigation that we did with the other big GI science conference, because maybe the grass is greener over there, right? So this was actually a paper that was accepted at the same conference that it's about, was awarded the Best Paper Award. And so the GI Science Conference is a biannual conference with a slightly different target audience than Agile. So that's why we thought it's interesting to look at this conference as well. However, the other important thing we wanted to find out is our method actually replicable, right? Does this work with other conferences, other papers? And we basically followed the same steps. Otherwise, we couldn't say whether it's replicable or not. There wasn't the author survey. We didn't have time for that, simple reason. But there were more papers, not 32, but 87 we looked at from 2012 to 2018, because we thought now we know how it goes, now we're quicker, and still a lot of manual work. 12 papers were excluded because they were too conceptual and not quantitative enough, but none from 2018. So that's also an interesting bit of information. So apparently Geosciences conference papers are also moving more towards quantitative analysis. So was our approach applicable? Short answer, yes. But as I said, it's labor intensive. So I think we've reached what we can scale up with a team of 5. It also turned out that was already indicating with the agile one that the pre-processing dimension is not very helpful. There's too much overlap with the actual analysis, and too often we were not able to more or less clearly separate the two. And computational environment is also of limited use. It relates mostly to processing time. And with the changing hardware environments, this is probably not of very lasting interest. So we suggest that future replications should drop the pre-processing and could drop the computational environment. You can try it out. We've published everything at this at Daniel's GitHub repository. So you can recreate our paper and plug in your own data if you want to. Very briefly, what's the outcome for Geoscience? So this should look familiar because it is familiar. The situation with data is a bit better. Fewer undocumented and unavailable, a few more which are actually available for download. But otherwise, analysis mostly documented but not available. Results same, mostly documented and not available. So more or less the same picture. Then we try to identify, are there particular combinations of these various dimensions? And so there are, let's say, 3 main strands. So what you see here is with unavailable input data, some papers, so most papers have at least available methods. Some also provide the computational environment, others don't. And most are documented when it comes to results. For those with available input data, it's interesting to see that for some reason, most of them don't tell us about the computational environment. But you see here already that from the relatively homogeneous results, there isn't that much diversity in how papers are reproducible or not. So are there any changes over time? Again, short answer, no, not much has changed. If anything, there's a bit of a worrying trend that in 2018, actually the input data was significantly less reproducible than the years before. So what does this mean for Geoscience? Well, overall, reproducibility is not great, like with Agile, but most papers are at least documented, so that's good. The main problem seems to be input data, where many score unavailable. And this is not, I should mention this is not a result of link rot, although that is a problem too. But if there was reason to assume that the data was available at the time of publication, we said, okay, this is available, right? So it doesn't even have to be available now, it had to be available then. And so we think this is a bit worrisome because of the increased focus on data science and the need for machine learning training data. So there were many papers that needed those. So again, very short comparison, and they are similar in terms of the 2 conferences. They are similar in terms of topics. There is an overlap of authors, noticeable but not majority, different geographic scope. But the big difference is Agile has this institutional framework which supported our ideas and supported our initiative. With Geoscience, this is a bit more difficult. So the question is, what can they do? And there is no final answer to this. And in the interest of time, I will jump over this because I would spend 5 more minutes or so on the question of reproducibility in education. Because ultimately, if we want to achieve a change of culture, we need to start early. We need to start when we train scientists, right? And so as part of these efforts, I did a senior university teaching qualification project on this. So basically, that's a bit of research on how to teach at a university. And the challenge that we have is, indeed, we have more data science in our geoscience curriculum. We have more computational work. But there are few materials available for this. And a lot of the academic skills teaching in our curricula focuses still on more classic academic skills, training and assessment. So I'm not saying that this is not what we should do, but the knowledge is tested in exams. Project work by students often is not shared within the course or even beyond it. The process is often less important than outcomes. And yeah, plagiarism is the ultimate sin, absolutely. But there is a bit of a problem because it also makes people refrain from reusing other people's work. So there's this tension between do not copy and pass it on as your own, but please share and reuse other people's code and data, right? So how do we deal with this in an educational environment? And we do have a new MSc program, relatively new, we're in our third year now, called Spatial Engineering, which is project-based, which addresses wicked problems and where the process is supposedly more important than the outcomes. So that's where I did this little project of mine. And what I did was that I tried to, let's focus on the implementation here. So I tried to have the students, after some initial lecture, have them do hands-on practicals to learn about reproducibility from the two perspectives, not only from a publisher, but also from a reading perspective. And let them create a reproducibility plan of their own project work. So a plan where they say, this is the level of reproducibility that we want to achieve, and that's how we are going to do this. And then the other project groups would look at these plans and comment. So there was some peer review of these reproducibility plans. And ultimately, I would try to see whether the final reports that they have to submit at the end of the course are more reproducible than in the previous years. So this peer review happens about halfway through the project, and the results are not overwhelming. I'll admit that, but what we can definitely see is, so again, these are the average scores, you remember, from the 4 levels. What we see is from 2019 pre-intervention to 2020, when I did the first run of this, there is an improvement. I don't dare say this is statistically significant. The sample size is again too small, but there is an improvement. And the number or the share of reports, of student reports, that is at least has basic reproducibility, so documented in all criteria, has significantly increased. And students, so here they are asked about the different elements of the teaching materials, and the majority said it's quite useful or very useful. On only very little disagreement here, very few that said, no, this didn't help me at all. So the plan that I have at the moment is that I would like to try to expand this in other MSc programs that we have, because these materials, this intervention seem to be useful. I would also like to find out whether there's an impact on their actual thesis research at the end. But unfortunately, the pandemic got a little bit in the way, and a survey that I tried to set up just too few responses wouldn't work, and so on. So there are a couple of suggestions what you can do today, and these are very basic, and I trust that most of you are very much familiar with those. So I will jump over them. However, even using Jupyter notebooks, for example, doesn't seem to be the panacea for the problem. There is a study on 1.4 million of notebooks, and well, only 1/4 of them ran without any exceptions, and only 4% produced the same results. So it's not, it's a process. So for the last slide, I've completely ignored qualitative research, right? That's not very nice. I'm not trying to say that it's not good science because it's irreproducible, because I've done quite some qualitative research myself. Several projects that I've involved in had many interviews, in-depth questionnaires, focus groups, and so on. So that's not what I'm trying to say. The problem is that I'm not sure how to make it more reproducible. It requires, I think, a different approach. And let's remember here that reproducibility is a spectrum. So the idea would be to make also qualitative research as reproducible as possible. But it doesn't mean that if some process is irreproducible, it's bad science. But how can we do this? I don't know. Maybe someone wants to volunteer and find out. So that's it from me. Thanks a lot for your attention and this tour de force through a couple of years of several activities. And I'm looking forward to your questions.
Thank you very much, Frank. That was a very nice and interesting talk. So yeah, I would like to give the floor to the audience. Are there any questions? Yes, there is one. By Caspar at the Open Science Community, I think it's Utrecht, right? You are working on a member initiative about open science, including reproducibility for qualitative research between educational science and anthropology. We should talk. Yes, that sounds interesting. Do you want to share some first ideas?
Well, I'm not the expert, and it was also not a question, which is why I hid it in the chat, but I was very enthused about this presentation. Actually, maybe I can come up with a question. So the reason I joined is because I published something called the Workflow for Open Reproducible Code in Science, WORKS. And there we boiled down the requirements for reproducibility to 3 pillars. And the first is dynamic document generation, such as your Jupyter notebook that you mentioned. And the second is version control, well, such as Git, which is being used. And the third is dependency management, such as Docker, which is being used. Am I missing something according to your research?
Probably, but I wouldn't know what exactly right now. From what you've told me, the 3 I would fully subscribe to, very important. But I think they work at a bit of a different level. Right, so we looked at this at a very high level, and these 3 elements then would be concrete measures to make parts of the analysis indeed more reproducible. So it would address the skills and tools that authors need. So it would be great if you would indeed, if you haven't done so already, publish this as open educational resources, for example, and I'd appreciate if you could point me to any link where I can have a look. It sounds very interesting.
Can do. Yes, everything is openly available, and there will be a workshop this coming year.
Great, because it also, so one thing that we also discussed in our group was very often, so where do we actually want to stop? Where does the burden of making it reproducible end between the author and the user? And some of our group, for example, very much like the idea of a fully one-click reproducibility approach, where you have, for example, a Docker container that you share, and then this should work out of the box. While others, me included, I think this is nice if you can do it, but to be honest, I don't have the skills for that. All right, so this is an additional skill set that I would need to get. And I really wonder whether we can expect from everyone to have it. So if you can, because it also requires then the skill set on the other end, right? So I need to be able to use Docker, for example.
Yeah.
And indeed, at some point, then I wonder, at some point, at which point are we going to exclude people, researchers, from the discourse, right?
Yeah, this is a really good question. I think that the platform of open science communities fulfills an important role here because education and peer-to-peer education partly fulfills that lack of existing knowledge. And the second thing is, I think that the open science element of team science will help address it. Because as you rightly point out, not everybody can have these skills. But some of us have more of those skills than we need for our own research and could benefit from working together with others who have more domain-related knowledge.
Yes, and I want to highlight here that the community of reproducibility reviewers that we have now for the Agile reproducibility review is a great community, and I really hope that it turns out to be sustainable and will continue in the coming years, because I've learned a lot. So if you have a problem with reproducing a particular paper because you lack some skills or so, you can easily ask a colleague who you know who's also in this reproducibility reviewer pool to help out. And that was a great experience for me.
We have another question in the chat by Paulo, who is going to be the devil's advocate now. He would like to know, wouldn't one-click reproducibility mean that there's no real auditing or examination of the method and the results when reproducing them?
That would be the case, I think, if the for example, Docker container would be a black box that you cannot examine, and you would accept the outcome as is. But if you can look at every little wheel that's turning in that machine, then you can find out whether the steps that are being done actually make sense. And in that case, no, I don't think then there is an evaluation and auditing, right? But indeed, if we limit it to here's the machine, press a button, and then if the outcome is as expected, then it's reproducible. Well, yeah, then it's reproducible, but it doesn't mean it's automatically good science.
Yeah, I agree with that. What I would like to add is that this one-click reproducibility would make real auditing easily possible. Because I remember that I did a computational reproducibility study in which I took the code and tried to rerun it and then checked if the code is executable. And it took me quite some time to get the code executable without having the opportunity to take any look at the source code itself. So yeah, getting to the point until you, from the point that you can do auditing of the code and the method, this can take quite a while. So in this case, I think that one-click reproducibility would be helpful. Although I agree that this is a very high standard and you cannot expect that from everyone. But maybe this is nothing that should be done by the researcher, but maybe by support staff. All right, are there any further comments or questions? Karin, please.
Yeah, too many buttons to click. And I was triggered by the question or the answer by Frank on the reproducibility of that you would like to have one click and that you could reproduce everything. And it also made me wonder For whom are we reproducing? I mean, the idea of reproducibility is that you would repeat different steps, and that the process is transparent in order to ensure that we can check that what we do is correct. But if you would now automate everything, I mean, in order to make it for the next person easier, I think that's not the aim, isn't it?
I think, yeah, I'm afraid I will repeat a little bit what Marcus said, because I think we are thinking in the same line here. It shouldn't be the end goal, no. But at the same time, it can be very helpful, because if I want to replicate a study, then indeed I don't want to spend too much time on reproducing it. If I want to go beyond it, then ideally the time that I spend to redo it should be as little as possible. It should really only be that I fully understand what's happening and that I can judge then what I'm doing differently. That's how I would see it, at least for quantitative computational analysis.
Yeah, makes sense to me. But I'm also thinking, like, especially in terms of qualitative research, which is often much more difficult to reproduce, then having really explanations of these different steps that we take is very important. So I could also imagine that for quantitative research, for a reviewer to really judge whether the steps that someone takes make sense, whether the right equation was used or whether the right parameter values were used. So we could also have some kind of a middle way of, like some kind of a checklist, or I don't know, some kind of a guideline, which really, in order to really support reproducibility, this is the minimum information that one needs to provide for in a paper.
Mm-hmm. But indeed, I think ideally that is what a scientific paper should do, and it shouldn't be published if it doesn't do that.
Exactly.
Because the paper should explain to me why a particular method has been used and not another one, right? So the justification of choices and so on. So ideally, so yes, I really think that the like a reproducibility box isn't the solution to advancing science. It's the combination of a scientific paper or post or whatever form. I think we also need to move away a little bit from the traditional model there, accompanied with whatever supporting material you can provide, data, maybe full transcripts from interviews, if that is possible and can be properly anonymized, right? And so on, and the method. So the whole package counts, not in a particular element.
Raul, I see your hand.
Yeah, thank you, Marcus, and thank you, Frank, for the presentation. I don't have questions, but I have a couple of comments I would like to share, and maybe they lead to questions, I don't know. One is you keep, and we just have a discussion with Karin on separating science according to their qualitative and quantitative character. I tend to think of it, especially when it comes to reproducibility, from a computational and non-computational point of view. And I think that most of what you said is really computational reproducibility and not so much quantitative science reproducibility. Or one is a subset of the other. That's one comment. And the other one is, I think you made a very clear point, which I agree very much, that the reproducibility is kind of on a spectrum, and that there are different levels of reproducibility. I also think it's kind of multidimensional. So we are not thinking here of reproducing maybe rerunning code, that's in our mind. But what about the reproducibility of the findings? Even if the code doesn't run and people have to do their own code, can findings be reproduced from a particular study? Or what about the reproducibility of an experiment? And then much more of at a philosophical level, can findings, experiments be reproduced for all the science that we do? because some phenomena that we study is kind of by definition, by nature, unreproducible. Or it only happened once. You need to be there at the right time to be able to make that observation. So you cannot reproduce the experiment. So how do you look at these things?
Yeah, I'm afraid I can only give a quite generic answer to this important comment, and it's that indeed, as I said before, if something is irreproducible, it doesn't mean that it's non-valid science. But the question is, did you try as much as possible to make it reproducible? And if it's not possible, then there are still lessons to be learned and important insights to be gained. But it means that, for example, it will be much harder, as I've tried to explain in the beginning, it will be much harder to replicate the study with different input data, different methods. And so it will be harder, not impossible, but harder to come to some wider insights based on these kind of one-shot experiments, I think.
Okay, thank you. Just if I can, sorry, very fast. I know that we are running out of time, but maybe we need to think more in terms of transparency, which is a word I also heard here multiple times. Maybe we need to insist more on our research being really transparent, and then reproducible is part of it. And then I would like to share the news that the open science communities in the Netherlands are starting also a discussion now, and maybe a special interest group will be formed, or some kind of Dutch reproducibility network will be created in the coming weeks or months. So I'm in the loop and I can keep people informed. But so you know, there is a national discussion like in other countries. Germany has a German reproducibility network. UK has a reproducibility network, and maybe the Netherlands will get one linked to the scientific communities, the open science communities. Sorry.
Yes, and I'm also very much looking forward to see how this whole agile thing plays out over the coming years, because that will be, I think the critical moment comes now, whether it is indeed going to be an established practice with improving results or not. So the outcome is unknown, and I'll keep you posted. I see that Mike has his hand up for quite a while, I think.
Yes, thanks for your presentation. I'm sorry I missed the first few minutes of it, but addressing your issue on qualitative research and reproducibility, the best we can do in qualitative research is to reproduce method. Okay? Because in quantitative research, we don't worry about things like ontology and epistemology. It's a rather simple form of research. Okay? No matter how complex the issue you're dealing with, the fact that you can just apply the epistemic approach and do the same thing over and over and over again doesn't make it particularly more valuable than something that can inquire properly. I mean, we're looking at qualitative research and the problems. What about critical research? You know, we start saying, well, it's value laden as well. So we're only scratching the surface here, and reproducibility is just an issue of having an explicit method and showing that you follow a method accurately and honestly, and making your research visible in all respects. Yeah. And the fact that you don't come out with the same answer as somebody else who did similar research usually would imply that the data and circumstances that you're dealing with is different. But if you stick to a chosen method honestly, and in a way that it can be reviewed accurately, then that's the best you're going to do in qualitative and critical research. So the reproducibility of the mathematical sameness of a calculation, it's unrealistic because it touches very little of reality.
Frank, do you want to address this? Maybe in a very short sentence because we are running out of time.
And I actually have to go to another meeting, already late. So yeah, I can't say that I disagree with you, but again, I think that the point of the exercise, for me at least, the point of doing science is not to stop at a single instance of some insight or some observation, but to find out whether this is also applicable in other circumstances, and if so, in which circumstances and contexts and so on. And to do that, I have to understand the original study as good as possible. Otherwise, and there it doesn't matter whether it's qualitative, quantitative, computational, or whatever. If I don't understand, the more I understand about the original study, the better I am going to be able to interpret the outcomes of another study. And you can call it transparency. That's necessary for reproducibility. We tend to call it, or I tend to call it now reproducibility, but I'm really wondering whether it's just not the other side of the same coin. And a lot of the reproducibility and replication issues and discussion originated in, for example, psychology research, which is a mix very often. I mean, I'm not a psychologist, so don't quote me, but it seems to me very often a mix of qualitative and quantitative methods, right? So that's where it's coming from originally.
I thank you all for joining this session. Frank, I thank you a lot for this very nice and interesting presentation. And yeah, nice that we have had again a good discussion. So yeah, thanks for joining, and I hope to see you in 3 weeks.
Thanks for having me, and anyone who wants to share thoughts and comment and so on, don't hesitate, drop me a line. I'm happy to get into discussion with you. Thank you.
Bye-bye.